Hello and welcome to the section 3.1 lecture video. This is the beginning of chapter 3 in our textbook, which is where we're going to talk in detail about what are called derivatives. We'll get more into what a derivative is in a little bit, but in section 3.1 specifically, we're going to look at tangent lines and the derivative of a function at a point, and we're going to talk about how those two are related. So if you want to follow along with today's notes or take your own notes in the note packets we're using, you can find these chapter 3 notes either in the Blackboard course under this week's link or in handouts on my math lab, depending on what format your class is in. So what we're going to start out with here is looking at the slope of a curve y equals f of x at the point p of x sub 0 comma f of x sub 0 is the number, the limit as h approaches 0 of f of x sub 0 plus h minus f of x sub 0 over h. This expression should look familiar. This is called the difference quotient. It's one way to write the average rate of change. And we saw in the last chapter that finding these limits does indeed find the slope of the curve. The line tangent to the curve at P is the line through P with this slope. Okay, so that's the first thing we want to be able to do. So let's go ahead and practice that a little bit. So find the slope of the function's graph at the given point, then find an equation for the line tangent to the graph there. So this should sound fairly familiar. We're just practicing something we did in chapter 2. So start out by plugging all the information into this limit. So that's going to allow us to find the slope. So I'm just going to put m equals the limit as h approaches 0 of, in this case, f of 1 plus h minus f of 1 all over h. And now we can plug that information into h. So this will be 1 plus h cubed plus 3 times 1 plus h minus f of 1, which they told us the point, so f of 1 is 4, right? Because f of 1 just means y, so minus 4 over h. And I forgot to write the limit, so I'm just going to add that in here, small. Okay, so now what we want to do is we want to multiply this all out. Okay, so multiply out 1 plus h cubed and 3 times 1 plus h. I'm going to go ahead and just do that, but if you wanted to check what I'm doing, you could. Just remember that this 1 plus h cubed is equal to 1 plus h times 1 plus h times 1 plus h. So when we multiply that all out, we get 1 plus 3h plus 3h squared plus h cubed is what we get when we multiply 1 plus h cubed out. We get that. Then we can distribute, so plus 3 plus 3h minus 4 all over h. And now what we want to do is we want to combine like terms. So this is the limit as h approaches 0 of 1 plus 3 minus 4 is 0. So those all cancel. And then we can combine the other like terms. So this is 6h plus 3h squared plus h cubed all over h. And so now we can cancel out an h, right? Because each of these terms has an h. So this is the limit as h approaches 0 of 6 plus 3h plus h squared. And now I can plug in 0. So this would be 6 plus 3 times 0 plus 0 squared, which equals 6. So that is the slope of our tangent line, the slope of the curve at that point. So now what we want to do is we want to plug that into point slope form, right? So this would be y minus y naught, which is 4, plus equals m times x minus x naught, which is 1. And then we just solve for y. So this would be y minus 4 equals 6x minus 6. Add 4 to both sides, and you get y equals 6x minus 2. Okay, so that's the idea. So when we're dealing with polynomials, this is the most likely thing that will occur. You'll need to simply multiply everything out, combine like terms, and then cancel out an h. Right, and we saw examples like this back in chapter 2. So let's go ahead and just look at a couple more together, the two other most common types of problems that we get involved with here, and remember how to deal with those. So in the second one, the setup starts exactly the same. So we've got our slope is going to be the limit as h approaches 0 of, in this case, f of h plus 8 minus f of 8 over h. Plug h plus 8 and 8 into the function, and you get the limit as h approaches 0 of the square root of h plus 8 plus 1 minus f of 8 is 3 over h. And remember that f of h is 3 comes from right here, right? Because when 8 is plugged into the function, we get 3 out because that's our ordered pair. Okay, and now we can do some simplification. So this is the limit as h approaches 0 of the square root of h plus 9 minus 3 over h. And now if you remember from chapter 2, the way we deal with this is we still can't just plug 0 in for h, because if we did that, this function would be undefined, and that doesn't tell us anything. So what we want to do is we want to multiply by the conjugate. Okay, so multiply by the square root of h plus 9 minus plus 3 over the square root of h plus 9 plus 3. And when we multiply those together, we get the limit as h approaches 0. H plus the square root of h plus 9 times the square root of h plus 9 is just h plus 9. The square root of h plus 9 times 3 plus negative 3 times the square root of h plus 9 cancel out. And negative 3 times 3 is negative 9 over h times the square root of h plus 9 plus 3. And so now combine like terms, so the 9 and negative 9 cancel. So this is the limit as h approaches 0 of h over h times the square root of h plus 9 plus 3. Now we can cancel out the h's. So this is the limit as h approaches 0 of 1 over the square root of h plus 9 plus 3. And we can now plug 0 in because that won't be undefined. So this will be 1 over the square root of 0 plus 9 plus 3, which is 1/6. So the slope in this case is 1/6. So that's the first part of the problem, right? In this one it was 6, in this one it's 1/6. And now we can find the tangent line itself. So this would be y minus 3 equals 1/6 times x minus 8. Distribute. So y minus 3 equals 1/6 x minus 8/6. And then we can simplify and add 3 to both sides. So that would be 4/3 plus 3, negative 4/3 plus 3. So this is y equals 1/6x. And negative 4/3 plus 3 is 5/3. Okay, so that's the idea. Now, in the last one here, it's going to be very similar to the two we just did, but one thing you should notice that is slightly different is they didn't give us an ordered pair. Instead of that, they just told us what x was. So we're going to set it up exactly the same way, but one step is going to change. So this would be m equals the limit as h approaches 0 of f of 0 plus h minus f of 0 all over h. And so then we're going to plug those in. Now, in the two examples above, they told us what we'd get when we plug in 0, but here they don't. So we're going to have to find that out ourselves. So we'll plug in 0 plus h, which is just h. So this will be h minus 1 over h plus 1. And then we find f of 0. So minus 0 minus 1 over 0 plus 1 all over h. So that's the limit as h approaches 0 of h minus 1 over h plus 1. Negative 1 divided by 1 is negative 1. 1 minus 1 is 1. So this would be positive 1 over h. And now, when we're dealing with rational functions like x minus 1 over x plus 1, most likely what we're going to end up with when we try to do this is a complex fraction. And the way we deal with complex fractions is by multiplying by the common denominator itself. In this case, there's only one denominator, which is h plus 1. So this will be the limit as h approaches 0 of h minus 1 over h plus 1 times h plus 1 times h plus 1 all over h times h plus 1. Simplify. Here, h plus 1's cancel, so that's just h minus 1. Here, we distribute, and we get h plus 1. And on the bottom, you can just leave that alone as h times h plus 1. Combine like terms, negative 1 and 1 cancel. H plus h is 2h. So this is the limit as h approaches 0 of 2h over h times h plus 1. And this is why we didn't distribute on the bottom, because now I can simply cancel an h. So this is the limit as h approaches 0 of 2 over h plus 1. Plug in 0 for h, and you'll get 2. So the slope here is 2, and we can do the same things we did with the first one. We can plug these in. So what you want, one of the things you want to remember is this right here is our y value for our point, our y naught. Okay. So in this case, it's going to be y minus, well, that's negative 1. So minus negative 1 equals the slope 2 times x minus 0. Simplify, and you get y plus 1 equals 2x, and then subtract 1 from both sides, and you get y equals 2x minus 1. Okay, so there's the idea. Those are the three most common types of functions we're going to deal with, at least to start with here. And that's how you would find the slope of the tangent line for each one. So what I'd like you to do is go ahead and flip to the next page, pause the video for a moment, and try doing these three. Okay, so take some time and try doing these three. Okay, so now that you've restarted the video and you've had a chance to try these, let's go through them together. So the setup for all of these is exactly the same as it was on the last page. So the slope is going to be the limit as h approaches 0 of f of x, sorry, not x, x naught. We want to plug that in. So 1 plus, in this case, 1 plus h minus f of 1 over h. So that's going to be the limit as h approaches 0 of 1 plus h minus 2 times 1 plus h squared minus f of 1, which is negative 1, over h. And then multiply this out, or at least start multiplying it out. So 1 plus h minus 2 times 1 plus h squared is 1 plus 2h plus h squared. And then minus a negative 1 is plus 1. All over h. And then we distribute. So this will be the limit as h approaches 0 of 1 plus h minus 2 minus 4h minus 2h squared plus 1 all over h. Combine like terms, 1 minus 2 is negative 1, negative 1 plus 1 is 1, so these three cancel each other out. H minus 4h is negative 3h, so negative 3h minus 2h squared over h. Cancel an h from all three terms, and this is the limit as h approaches 0 of negative 3 minus 2h. Plug in 0 for h, and you get negative 3. Once you've done that, you can find the line. So y minus negative 1 equals negative 3 times x minus 1. Distribute, and you get y plus 1 equals negative 3x plus 3. Subtract 1 from both sides, and you get y equals negative 3x plus 2 for the tangent line. So the slope of the curve at this point is negative 3, and the equation of the tangent line is y equals negative 3x plus 2. Okay, so there's one example. So now let's try another one. Okay, so we've got our slope equals the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. So the limit as h approaches 0 of 8 over 2 plus h squared minus 2 all over h. And now we want to do the same thing we've done before, which is get rid of the complex fraction. So multiply by the denominator itself, the most common denominator, which is 2 plus h squared. Okay, so that's going to be the limit as h approaches 0 of 8 over 2 plus h squared times 2 plus h squared. Oops, squared out here. Let's get that right. Minus 2 times 2 plus h squared all over h times 2 plus h squared. So in this first term, those cancel. And so we're just left with 8. And then that'll be minus 2. We need to multiply out the 2 plus h squared, so that's 4 plus 4h plus h squared all over h times 2 plus h squared. Distribute, and you get 8 minus 8 minus 8h minus 2h squared all over h times 2 plus h squared. 8 minus 8 is 0. So this is the limit as h approaches 0 of negative 8h minus 2h squared over h times 2 plus h squared. Cancel out an h. So this is the limit as h approaches 0 of negative 8 minus 2h over 2 plus h squared. Plug in 0 for h, and this becomes negative 8 divided by 4, which is negative 2. So our slope is negative 2, and we can now plug that in with the point to get the equation. So y minus 2 equals negative 2 times x minus 2. Distribute, so it's y minus 2 equals negative 2x plus 4. And then add 2 to both sides to get y equals negative 2x plus 6 for the equation of the tangent line at that point. Okay, and then last but not least here, find the slope. So this is going to be the limit as h approaches 0 of f of negative 2 plus h minus f of negative 2 all over h. So that's going to be the limit as h approaches 0 of negative 2 plus h cubed minus 2 times negative 2 plus h plus 7 minus negative 2 cubed minus 2 times negative 2 plus 7 all over h. Okay, so multiply these things out. So negative 2 plus h cubed means I need to take negative 2 plus h times negative 2 plus h times negative 2 plus h. So if you multiply that all the way out, you're going to get negative 8 plus 12h minus 6h squared plus h cubed. So that's the first thing multiplied out. Then I distribute the negative 2. So that would be plus 4 minus 2h plus 7 minus whatever we get over here. So negative 2 cubed is negative 8. Negative 8 plus 4 is negative 4. Negative 4 plus 7 is 3. All over h, and I forgot the limit. So the limit as h approaches 0. And now we should be able to simplify that a little bit by combining like terms. So let's see. So yeah, so I'm worried there's a typo here that I did something wrong. So let me check my work real quick. Oh no, I'm okay. Okay, so combine like terms. So negative 8 plus 4 is negative 4, plus 7 is 3, minus 3 is 0. So these actually all cancel each other out. And then we can combine any other like terms. So 12 minus h minus 2h is 10h minus 6h squared plus h cubed all over h. And now we can cancel out an h. So this is the limit as h approaches 0 of 10 minus 6h plus h squared. Plug in 0 for h and you get 10. Okay, and so now we can find the point. So y minus this, remember, was f of negative 2. So y minus 3 equals 10 times x minus negative 2. So that's distribute y minus 3 equals 10x plus 20, and then add 3 to both sides. So y equals 10x plus 23. Okay. So now on this page, we've been treating, and the page before, we've been treating this difference quotient limit as the slope of the curve. But it actually has several other names, and that's what we're going to look at to start out the next page. So the expression as given is called the difference quotient. If the difference quotient has a limit as h approaches 0, the limit is given a special name and notation. The name is the derivative of f at x naught, and it's denoted f prime of x naught. And it's written like this, so that's true, provided the limit exists. The following are interpretations of the limit of the difference quotient. So the one we've been practicing with is the slope of the graph, or the slope of the tangent line. Those are the two we've been looking at. So the two new ones here are the rate of change of f with respect to x at x naught and the derivative. So these all mean the same thing. So what we can do is we can use this idea of the limit of this quotient, difference quotient, to find things like instantaneous rates of change. So for example, this first one here is at t seconds after liftoff, the height of a rocket is 3t squared. How fast is the rocket climbing 10 seconds after liftoff? So what this is saying is the height is equal to 3t squared. So how fast is the rocket climbing 10 seconds after liftoff? Well, how fast something is going is the same as the rate at which its height is changing, right? Its position is changing. So if I want to find this answer, what I need to do is I need to find the derivative. I need to find the rate of change at time t. So what we're going to do is we want to let t equal 10, and we want to do the same thing we've been doing on the previous pages. We want to find this function. So what we're going to do, let me use function notation here instead of variable notation. So let's call this h of t. So what I want to do is find h prime of t. And to do that, I find the limit of the difference quotient. So this would be the limit as h approaches 0 of the function. So what we want to do is we want to plug in. So this will be h of 10 plus h minus h of 10 all over h. And don't get confused. Sorry about all the different h's, but I used h for height and I used it in there, so it's a little confusing, but all works. Actually, let's change these to capital H's for the height. I think that'll make it a little less confusing. And then little h is the one that's in the difference quotient. So now plug those into h. So this will be 3 times 10 plus h squared minus 3 times 10 squared all over h, and I'm taking the limit of that as h approaches 0. Multiply those out. So this is the limit as h approaches 0 of 3 times 100 plus 20h plus h squared minus 3 times 100 all over h, and then distribute. So this is the limit as h approaches 0 of 300 plus 60h plus 3h squared minus 300 all over h. The 300's cancel. And now all the terms that are left have an h, so I can cancel there as well. So this is the limit as h approaches 0 of 60 plus 3h. And now plug 0 in for h, and you get 60. So how fast is the rocket climbing? 60 feet per second after 10 seconds. So its speed is 60 feet per second at that moment. Okay, so that's the idea. So what I'd like you all to do is pause the video at this point and go ahead and try this last problem here. Okay, so now that you've all had a chance to try this problem, let's go ahead and do it together. So what is the rate of change of the volume of a ball with respect to its radius when the radius is r equals 2? Well, what we do is the exact same thing we did above. I want to find the derivative of that because the rate of change is the same thing as the derivative of that function. So we're going to find the derivative of the volume with respect, the derivative of v of r. So that means I want to find the limit as h approaches 0 of v of h plus 2 plus h. Let me try and keep my notation consistent. 2 plus h minus v of 2 all over h. So then we can plug those into the function. So this will be 4/3 pi times 2 plus h cubed minus 4/3 pi times 2 cubed all over h. Okay, so then we're going to multiply this out. So this will be v prime, this will equal, multiply out the cubed, right? So that's 2 plus h times 2 plus h times 2 plus h. So this will be 4/3 pi times 8 plus 12h plus 6h squared plus h cubed minus 4/3 times 8 pi. So that's going to be 32/3 pi all over h. And then I'm still taking the limit of it. So let me go ahead and add that in here. So then we can combine, distribute. So 4/3 pi times h is 32/3 pi. 4/3 pi times 12 pi h is going to be, 12 divided by 3 is 4. 4 times 4 is 16. So it'll be plus 16 pi h. And then 4/3 times 6 is 4. 6 divided by 3 is 2, so 8 pi h squared. And then 4/3 pi times h cubed is 4/3 pi h cubed. And then minus 32/3 pi all over h. The 32 over third pi cancels because we got a positive one and a negative one. And now everything that's left has an h, so I can go ahead and cancel out an h from each term. So this will be the limit as h approaches 0. 16 pi h divided by h just leaves 16 pi plus 8 pi h plus 4/3 pi h squared. And now if I plug in 0, I just get 16 pi. 16 pi. Okay, and so that is the idea. We're going to go and skip this last page because I think this video is long enough and this is not a necessary thing for us to cover. So that's it for section 3.1. I hope you enjoyed the video and make sure you're doing all your homework and all your assignments. And please feel free to reach out to me if you have any questions about anything in this video or anything else for the course.